So good morning to everyone. Today I'm going to give you a brief discussion about a semester project that I have done in semester 4 of university. This is an IoT related project. As you can see in the screen, the name suggests that the device, the project name is Pollutector. So uh, for a brief introduction about the project, I will show you some articles that I have grabbed from the recent newspaper documents. As you can see in the screen, let me focus you onto the left side of the screen. 116,000 infants killed within 1 month due to the air pollution in India. So every 1 month, 116,000 infants killed in India, right? So in also, if you focus more onto the other news headlines on the screen, you can see the air pollution and how it relates to the health and development concerns of the humans and other living beings. So in the middle, as you can see now, the current pandemic is also directly connected with the air pollution, right? But so you see some serious outcomes and consequences of air quality. But since these are all related to the foreign international level, so you saw some articles related to the all the articles are related to the India and other nearby countries, but mostly related to the India. But you didn't see any serious outcomes related to our country, right? But when I grabs to the recent news documents in Google, I found this alarming thing, right? The abnormal increase in air pollution levels in Sri Lanka. So do you think whether we will get these serious consequences and bad outcomes of air quality in near future? So we don't know. So I focus more on you to the air pollution, and let me give you some brief insights about the air pollution. So the air pollution. So if you want to find if you want to find some insights about anything in anything, we go to the Wikipedia, the knowledge base. So let me focus you to the definition in the Wikipedia about air pollution. Air pollution is the presence of substances in the atmosphere that are harmful to the health of humans and other living beings. So this is obvious, right? You know this definition from your early childhood. So do you know what are the pollutants that affects to the air effects in the air pollution? So according to the World Health Organization, they have developed certain guidelines regarding the certain gases that are seriously affects to the human beings and other living creatures, such as ozone, nitrogen dioxide, sulfur dioxide, carbon monoxide, and specifically the particles, particle 1, particle 2.5, and particle 10. So in recent researches, it has been shown that there is a high connection between air pollutants and the diseases like lung diseases. So also in industry developing countries or third world countries like us, the human health is highly affected due to the air pollution when there is no such big infrastructure to monitor and control it. So you know, in India, if you search what is the air quality or air quality level in the India, it will always say that it's bad in New Delhi. But even though there is an infrastructure, a little bit infrastructure to maintain, but it can't keep the control level of the air quality. So obvious questions in your mind is right now will be the air pollution is bad, right? But how can you measure it? Is there any scale Since you see in the screen, there are several factors affecting the air quality or the air pollution. So since there is a combination, how can we measure this? So as you see in the screen, the measurement is air quality index. So it's abbreviated the AQI. So it's the air quality index. You can think it as a ruler or a measurement tape or a yardstick, which runs from 0 to 500, and 500 being the hazardous level and 0 being the good level. And if the level goes high, the greater the health concern is. So in your right side of the screen, you can see the yardstick and how it populates. So the green is good and the maroon is hazardous. It's about 300. So the air quality index calculation and the pollution monitoring is run in air quality monitoring stations, which are big infrastructures, and they are pretty much accurate and no concern about their preciseness. So, but even though they are accurate and precise in and it's good in every manner, there are some drawbacks, major drawbacks of such stations. They are huge in size and they have the high complexity. Even a well engineered one, even a well engineered person can't be just control this huge infrastructure. And the other thing is the high maintenance cost. Just to measure the air quality index, you need to pay hundreds of thousands of dollars for that. So so there is a huge need of portable measurement of air quality to avoid hazardous situations. So think about an event that you are going out with someone. So you step out and you don't know the air quality. So let me assume that the air quality is in orange level. So it's affects to the sensitive groups, and you are being the sensitive. You are being in the sensitive group, but you don't know what's the air quality is, and you going out, and since the air quality in orange level, you see any visual impacts on the air color or anything. So you go out and you come home, and after 1 month you get the serious consequences of the air quality, and that's it. That is why if you have faced to the bad air and you can't now go back and correct it. So therefore, to overcome this, let me introduce you the Pollutector, the portable air quality detector. As you can see in the image, this is not portable, I know, because due to the COVID-19 pandemic, the PCBs are meant to be in double-sided, but due to this pandemic, we couldn't able to complete it. So we completed in single-sided PCB. So the device is little bit not in the portable manner, but in the near future, this will be improved to a double-sided PCB, and the size will be get reduced drastically. So now you have the question is, what is this Pollutector? There is a name, bit odd name, but what is this Pollutector? So let me focus you onto that. Pollutector is a device that is used to measure the various air quality parameters on the go. So if you're going out and you get the device, you can check the air quality. And if it is in the hazardous level, you can step in the house, right? So the device captures the necessary bad air quality pollutants levels, such as dust level, nitrogen dioxide, sulfur dioxide, carbon monoxide in your surrounding environments. The main features of this device is very simple and it's easy to use. You saw some infants, 116,000 infants died every month in India. So if you give this device to an infant, even the simple fragile creature, the infant can even operate this thing. But you know, the air quality monitoring stations, you can't, even the well matured one can't operate that. So another thing is this device is portable and can take measurement at any time. You have the device in your bag, just pop it out and just just check the air quality and keep in your bag. And so there are various modes available so that user can use it in different environments. Like if you want to check the air quality in your indoor, so you go ahead and there is a mode for that. And if you go on to check, just pop it out and check, just use the there is a mode for that also. And this has the lowest maintenance cost. So and the sensors are easily replaceable. So if the sensor get malfunction and you find that the sensor is not working, just grab the device, remove those screws, uh, get a sensor module and apply it, and boom, you are out with the new device. Okay. So obvious question will be, now you have in the mind is how it works. You know that the device is working fine and it's easy to use, and how the easiness is going to be happening in the device. So let me focus you on the user journey of the device. The first, user needs to log into the app and turn on the Wi-Fi hots of the mobile device, actually in the phone itself. The app will generate specific credentials to the related device. And second, the device will connect to that hotspot to log the data automatically. So after that, from the device, user need to select continuous or discrete mode. But in depending on the tire of tire, you will get the continuous mode, maybe not available in the app because it's related to the premium features of the app. So you have some questions about, what is the continuous mode, right? So there are two modes in the device. So continuous mode is like the name says, like you are measuring the air quality continuously. Like it is suitable for indoor air quality measurement. You can put the device in a room or in a living room of your home and monitor the air quality, even if you are out in the, if you are out with some other work. So the discrete mode is specifically designed for portable measuring. So if you are out in the town, so you get the device and check the air quality, and you can visualize it by using the app. So I think you have some idea about what are the modes available. So there is a slide switch in the device. You can select between continuous and discrete mode. So after that, the data is logged into the database and graphs will be automatically populated. If any of the parameter goes higher than the acceptable levels of World Health Organization, the alarm will be triggered on app and device itself. The hazardous level of air quality is indicated through the built-in LED of the device. So you saw some yardstick in the previous slide. So we will indicate the air quality in the specific color related to that region. So components used, we have used a main boards as Arduino Nano, and this actually get the data from the sensors and make the work of run the actuators. So ESP32 is mainly for the communication gas sensor MQ135, the temperature and humidity sensor, which is DHT11, the optical dust sensor. The name is, I can't say the name. So in the power, actually we have used 3.7 lithium ion battery, and to charge that we have used a lithium battery charger, which is a USB charging device, a USB to power, USB charging to power the device. So the actuators are actually the buzzer and the LED. So how the structured layout, how the block diagram, how the interconnection works. So you see the sensors grab the data from the surrounding environment. It uploads the data to the Arduino Nano. Depending on the various levels of the sensor data, the actuators will trigger the LED and the buzzer. So after that, the data is logged onto the node MCU or the ESP32, and the ESP32 will obviously give the data to the cloud, and the cloud will get the app will get the data from the cloud. So in the below, you can see a flow of the data. So first the device gets the data and it sends to the MQTT, which is a broker architecture. So after that, it will send the data to the Firebase, and obviously the app get data from the Firebase. So let me focus you onto some of the snapshots of the app. You can see left side the login screen, and the middle the continuous mode, and the left in the right side you can see the graph. So ignore the padding of the thing because that's not the image is not in the format of the phone. So that's it. Sorry for the interruption in the middle. Thank you. Is there if there is any question, feel free to ask.
No worries about the interruption, but fantastic presentation. Actually, really well done. I think well prepared and very clear on what you were presenting. So really well done. Very nice presentation. So does anybody have any questions or suggestions or whatever regarding the problem or the solution that we just discussed? So this was a university module project, right?
Yeah.
So since the module is now over, is this still happening, or are you guys done?
Yeah, we are just developing this thing right now. Since in the middle, I just talked to you about that the PCB size is a little bit bigger, so that we cannot make it to the portable level. So that we are just planning to shrink the size using double-sided PCB.
So what's the size of that device now?
It's around bit bigger, but I can't remember the size. But it's not actually the portable. Like it's two sizes of the phone. So since that's it. But the components are very small due to the two-layer single layer PCB. The size is a little bit bigger. But we have the idea of designing it in a way that how the size of the AirPods, so that you can just open the thing and just check the thing out. But now the size is a little bit bigger.
So the ideal size is around like AirPod case, right? AirPod case size, like this size.
But so, maybe a little bit bigger, but the size is will maybe similar to that size.
So it will only have an indicator which shows which level of the and a buzzer, and that's it, right? No screen, no anything need to be there in the device. Ne?
All the thing is done through the app, because like if we include a screen, it will drain battery, and user needs to start this charge these continuously. But the users don't like that, no? So that's why we integrate it to the app.
Yeah. So how does this device connects to the hotspot of the like why does this device need to connect to the phone, like mobile hotspot, or like this device need to have internet, right, to log its data to the IoT, whatever the platform you want to use. But this does not necessarily need to connect to the phone's
Yeah,
mobile Wi-Fi or anything, right?
the question is right, because no need to connect to the hotspot, but for the initial purpose we did using hotspot. But there is a method where we can use the data from the get the data using the Bluetooth,
Yeah.
and log the data from that to the cloud. Yeah, but due to the limitations and some other, like there were a little bit constrained about the ESP. We have used ESP 8266 that was given by the university, but if we use ESP32, there is the inbuilt Bluetooth connection, so that we can use that way to log the data from the get the data from the device and log it using mobile connection of that. Yeah.
Yeah. So for this to be like really, really productive and efficient, I think this need to be connected with the mobile using Bluetooth,
Yeah.
and the device itself should not upload any data to internet, right? Because it will
Yeah.
like, consume a lot of energy, and we'll need a mobile SIM or whatever.
Mhm.
Since we don't have Wi-Fi everywhere. Mm, then it's really good. We can like if you think of this as a separate business, just not only the device, but with the device you have the mobile app, and with the mobile app, if this is a thing, we can promote some air, like this detects the air quality and air quality problem. You can promote air quality solutions. This is not a solution. This is just the finding the
Yeah.
problem. So you can suggest the solutions through the mobile app, as well as if
Yeah.
this becomes like if you can get this to the market. So
Yeah.
uh, with it not only comes the uh, risk of like not only gives the indication or the alerts, but also some sort of paid promotion, whatever. But it whatever it does, it will help. So
Yeah.
it has, it's
Since
nice.
the thing is, like in Sri Lanka, the air quality is not actually just there is no concerns about that. But I think in India, every year there are huge amount of deaths due to the air quality.
Yeah, in Sri Lanka, it's not alarmingly bad. I think
Yeah.
in
But
Nuera,
recently there
like
was,
Candy, there's a little problem or
yeah.
something with air quality, but not everywhere we have that big issue, right? But
Yeah.
very nice, and I like really enjoyed. If anyone have any questions, please feel free to ask.
Dineth, is this related to IoT project?
Yeah.
Uh,
Mm,
Okay, I have a question for you. Actually, a joint question to you and Madhushankar. So, in moving towards the concept of smart home automation, how would you integrate this device to what Madhushankar presented last week to improve the overall, to improve the quality of Madhushankar's project?
Hmm.
So you
Mm,
both,
maybe we can place in the kitchen or garage somewhere.
yeah. So you
yeah.
have to, yeah. So you have to
Okay.
think about the communication between devices as well as the size of the device, and also the ability to connect to the same source to a cloud door, to a mobile phone. So you can use anything. So how would you integrate your device? And also Madhushankar can answer this as well.
It's actually something you can think about and like think about in the future as well. Future means like we can discuss it at some other time if you need time to like think about things like properly, but let's discuss it now. For the time being, it's really good, like really good suggestion.
Mm.
So
So
Madhushankar has introduced us as home security system, and you have introduced us air pollution detector. And I think if
The
we are
question therein lies the like answer as well, right? In some sense.
yeah. So
Yeah.
I want you to suggest a way to integrate your device to what Madhushankar suggested last week. I want your input. I already have a suggestion, but before giving that to you, I would like to hear your comments about it.
So
do you remember about the thing
yeah,
that we discussed last week?
yeah.
I
The
think
thing is, if the Madhushankar's device is a separate one, right?
yeah,
Yeah,
I know.
okay. No. I mean, asking like if the Madhushankar's device is separate, it can it's operate in a separate like there are two devices, right? My device and Madhushankar's device.
Yeah,
Okay. So
but after you however, after you integrate this, your two devices, it has the functionalities of identifying unauthorized entrances as well as gas leakages and some other air pollution scenarios as well. So you
So
already have
actually, can we detect the the gas leaks and burning? Not think about burning, but gas leakages or something of that similar using the same device, or
yeah,
we
there
can
are
include some other if it is necessary. You can include some other sensor for that
that.
purpose specifically as well. No?
Yeah,
If it is not increasing the cost too much.
So your concept with Madhushankar's concept.
yeah. So one way of integration is like yeah,
No,
one way of integration is
I don't need an exact answer. Just a rough suggestion would be enough.
uh so from Madhusankar's device, so get an instance like the device is in the home, right? So it's in the continuous mode, so it's measuring the air quality continuously. So from Madhushankar's device we can get the input whether there are people present in the house, right? So after getting the data only you can update the air quality, right? If the from Madhushankar's device the people are out, we can measure several other aspects, like the gas leakage, gas leakage and other air quality levels which are not actually bad, actually which are not actually important to humans but important to the overall like the gas leakage and other like the SO2 levels or something like that.
Yeah,
My inclination will be like that,
yeah.
because like from home security okay, go.
That's enough. Thank you. Yeah, I'm very happy about the answer. So I would like to see an integration on these two devices. So talk with Madhushankar and come up with an, a solution concept
Okay.
if you are interested.
Yeah, I'm interested, but first of all, I was focusing on reducing the size of the device very much, because
Yeah,
like the thing is, yeah, we can develop separate device for indoor measurement. Like if you can like just put a device inside or fix it to the wall. So first of all, I would like to focus more about portable, and we'll focus on that too. Yeah.
yeah. As you said earlier, so if you are going to fix it uh, inside a home, inside a house, so you will have to use the continuous mode only, right?
Yeah.
Yeah, so obviously you can reduce the size. I mean, a whole other part is going to be missing in that device.
Yeah. No, the continuous and discrete mode is like it's a software related thing. So
Okay.
the device won't be won't get the size won't get affected. But the thing is like we don't need to consider about the size if you are using Indo that much.
Yeah. If you're using it in Indo, the accuracy and the durability will be the most important things.
Yeah.
And
And even we have the Wi-Fi so that
yeah,
we can just continuously. Then there was an integration regard, but I didn't but there was a machine learning part going on with that too, but we didn't actually focus on that. But we separately generated some machine learning models using machine learning models to predict the air quality, like, but we need more data, but those APIs uh, doesn't allow us to get the data. So from the device itself, we get the data, and after analyzing getting the data for months, we can just analyze and give some predictions related, like some in some cities, like, so I see some temperature increases in the night and air quality increases in the night, so we can give some suggestions through that also.
If you are
how
going to
accurate is the measurements?
Yeah, with but some it's the temperature and the other pollutants are mostly accurate. But overall air quality is somewhat differentiated because the other stations get data from multiple stations. So after that they integrate it together and get a final value. But for measuring air quality in your surrounding areas, this is good, I think, because even if they give even if they give the measurement is good, in some areas there would be like bad air quality, right?
Yeah,
And
yeah.
yeah,
How
that's
did
it.
you hide? Like, how did you guys like fine tune this, like measured and
Yeah, there are
controlled
some
tuning?
the in so you mean in the device itself, if the sensors get a spikes or something, we go for roll of mean and just remove the spikes of the data, and we take around 20 measurements from the data and get the we use roll of mean and just remove the spikes and get the average value, so that the accuracy is little bit higher than taking one measurement. And yeah, for fine tuning,
No, I mean like
yeah.
did I think you might have not done that so far, like doing something like going to a place where the air quality is actually bad, and
Yeah,
we can measure and see what's
yeah,
the
we have
value that this is reading. The
we
reading.
have tested with some some other, like if we have manually given inputs, like we have put some lighters in front of that and get the values. So actually the acceptable levels will increase, but don't know whether it is like right or wrong, but will increase, like it will be similar, like come near to that, but not the actual value, because the sensors are a little bit some cost effective, so therefore they won't like really good accurate, but there are sensors that are more accurate than this in the market.
Hmm. Yeah.
if you are going
Think,
to develop this as a marketable product, so either if you so one possible solution is that you will have to do some benchmarking on this.
Hmm.
Otherwise, you will have to uh, do some trial and error experiments and give a error percentage or something. So you predict this value with this much of accuracy and with this much of an error. So have you thought about that?
Yeah, if you are going to market this thing, we are going to do that, because like even if we the sensors that we are use are like mostly type hobby type ones, so they are just normally available in the market. So if we go to the sensors which are from Bosch and like from Adafruit, they will be the accuracy will be on there in the sensors itself, right? So there won't be any overall device. We have to do some benchmarks and some test regarding that.
I'd like to add a bit more on my question. So you always know that there is a trade-off when when you make a device a cost-effective one. So you always have a trade-off of dropping the accuracy a bit.
Yeah.
So my question is, how do you convince a client that buying this product to this much of money is worthy? Is I mean that instead of buying a high quality product with high price, buying this device to a low cost, low price with this much of accuracy is worthy.
Yeah, by
actually, I don't need an answer right now. I mean, have you thought about that? So is
yeah.
So you get what I say, right? You get what I say, right?
Yeah. If you are marketing, we have to concern.
So there are lots of trade-offs like that.
Yeah. And what we can do is like we can benchmark with the existing high price one and give some charts about that. That's what most companies does, right? And they will validate the trade, they will validate the cost to the effectiveness thing. I think we can give some graph like why this device is even cost effective, but you can get nearly the same quality level as the
that's great. Yeah, nice.
So let's wind up.
We are not actually thinking again. First of all, we just want to get the device and sort it out, and then afterwards we have to think about marketing, because there are some lot of researchers that we are going to need to go through, because the sensors, we can make the thing even when even using some other sensors, because the sensors are a little bit the price is a little bit lower, even if we use some sensors from Bosch and stuff. But the thing is like the accuracy thing. We have to really concern about that if you're marketing.
I mean, just to be honest, are you? So this is a semester project, right? So after you get the grade, you just discard it away. So that's the truth.
No.
Most of the cases, it's like that. I mean,
but I really like I even in my interview I also said that I really like to focus my career using IoT. So that I'm really focused.
What I wanted to know is that if you really have the passion to improve this, please talk to Chamira. He will have some insights on this.
Yeah.
That's what I wanted to tell you. I mean, if you really need to work on this, I think it will be good to talk to him.
Yeah. And my team is also concerning about improving this thing, because like there are like not in Sri Lanka, but in other countries there is some huge potentials, and even the high costly devices have some serious errors. Like in I know some cases in Australia there are in the smart city development, there are air quality measuring units which are like around 800 Australian dollars. So even they have some really bad measuring things. Even the government buys those stuff and install that. Even when halfway through, their measurements are wrong, and the sensors won't work. Like there are serious problems, but with that amount of money we can develop a good one. But our target is to measure, like our target is to go as small as possible and keeping the accuracy and preciseness at the acceptable levels.